Hi guys, Buildzoid here from Actually Hardcore Overclocking, and today we're going to be taking a look at the first of the Z390 new Z390 motherboards, the MSI Z390 Godlike. And the thing is, as far as I'm concerned, the only thing godlike about this board is the price, because it is $600 last time I checked, and that is quite insane considering what you're like actually getting.
Before that, this video is brought to you by the Corsair Strafe RGB Mark II mechanical gaming keyboard. The Strafe Mark II uses Cherry MX switches, available in MX Red and MX Silent, and uses the elevated keycap design that has become part of Corsair's keyboard identity. Elevated keycaps make the keyboard much easier to clean with a blast of compressed air and limit dirt buildup. The keyboards use a metal body design and have received praise from us in the past in old reviews for high build quality. Learn more about the Corsair Strafe Mark II at the link in the description below.
Before we get into all the VRM stuff, let's just talk about some of the features scattered around the board and address this PCIe slot situation, because I saw a lot of comments when photos of this board first came out talking about how this is totally going to have like a million PCIe lanes. But for those of you who know how for those of you aware of how you actually get a million PCIe lanes out of a CPU with only 16, you can probably already tell that there is a significant lack of a very big, very expensive chip on this motherboard. There's no PLX chip, or no PLX switch anywhere here. So the thing is, these PCIe slots are wired as 16 CPU. So that's an X16 on the CPU. That's an X4 slot. So that's a 4 on the CPU again. This is an X8. And the last one is a X4, and that's on the PCH. And the reason for that is simple. There is no PLX chip. So what a PLX chip is basically it goes between the CPU and the PCIe slots, and it allows you to take, 16 lanes or 8 lanes of PCIe and kind of turn them into like 32-ish, kind of. The problem is you're still, ultimately, if you want to move a lot of data to the CPU, you're still going to hit the limit of that 8x slot. But it basically does mean that as long as no other device is using the connection, something can actually get a full 8x connection or a full 16x connection to the CPU, because the PLX chip acts basically as a PCIe switch so that the CPU can communicate, can better sort of balance the available lanes between the devices. This motherboard does not have that, and in my opinion, that chip would have been like a really good justification for the price tag that this comes with, because the PLX chips are like $50 even when you're buying them in bulk. They are really, really expensive, and there are a couple Z390 boards that actually have that chip. This one's not one of them, even though it looks like it really should have it, considering how many PCIe slots it has. But yeah, it doesn't, and honestly, that to me is hugely disappointing, because it's like the board's $600. Like, if you don't have a PLX chip, what do you have? They have a postcode, so that's a good thing, stars in terms of OC features. Also, down along the bottom edge, you get a switch right here, which allows you to control these 3 PCIe slots, so you can turn those on and off. You do not get control over the PCH slot. So basically, also with the situation on this motherboard, it only supports 2-way SLI, but you can actually run like 4-way Crossfire off of this, because Crossfire really doesn't care what kind of bandwidth you actually have hooked up. It doesn't necessarily run great when you run it through a PCH, but you can do it. SLI won't let you even enable SLI if some of the GPUs are on a 4x connection. So yeah, this only supports sort of 2-way SLI, even though it looks like it could support 4-way. Well, it doesn't. Next to the PCIe on-off switch for the CPU lanes, you get a BIOS switch, so the board does have dual BIOS. The BIOS chips are soldered onto the board, as there are no socketed chips anywhere on this motherboard to be seen. So that's kind of unfortunate, but hey, at least there's 2 BIOSes and you do have a switch to control, switch between them. So as far as I'm concerned, this is good enough. If you brick one, you still have the other to use for unbricking the other one. So that's nice. Then we get the break your CPU dial. I really, really recommend never ever using that thing. Like MSI has they've built motherboards with this dial and the dial's just loaded like with completely stupid settings. Like settings so bad that even with liquid nitrogen, they still wouldn't be viable. And it's just like, I have no idea who decides some of these profiles. It might have gotten better recently, but honestly, just don't. Like, it's better if you just do all of your tuning manually, because most of these OC these are all just sort of preloaded profiles, and the way they make these work is by giving them way too much voltage, and sometimes even that isn't enough to make them work. So it's kind of unfortunate. Below that, we do find two rather useful buttons. You have a OCFS1 here, which I assume that means failsafe, but the manual basically calls it a force entry to BIOS. So that is a safe boot button. It'll get you into BIOS even if you have bad settings set up. You have a retry button, which if you have memory training issues, that can be very, very useful to get the system to post memory settings that are pretty hard to run. These are both basically extreme overclocking usage only, especially the retry button. If you need the retry button to get your memory settings to boot, they are probably not stable enough for daily usage. So, it's not exactly helpful for your daily system, but it is nice for overclocking and benchmarking, basically, and extreme overclocking, that kind of thing. So next to that, we find sort of the standard button loadout of reset and power. And quite frankly, I am not a fan of having all of the nice OC functionalities except for the postcode all on the bottom edge of the motherboard, because, well, I mean, the board technically doesn't support it, but you could, doesn't officially support it, but you could totally do a crossfire setup where, you can't get at any of those functionalities, but because they'll be covered with a GPU. But considering the PCIe layout, that's not a huge issue, but I'm still not a fan of having like the postcode miles and miles away from the rest of your sort of overclocking features and functionality, because it's just like, if you have this on a test bench, right, it's like, which edge of the board do you prioritize to be near? The postcode or the buttons? And a lot of the time you end up with a GPU obscuring one or the other, and it's just kind of annoying in my opinion. So they should be together, but MSI decided to lay them out like this. I guess, I mean, it's not... they kind of have a lot of space they could have used better up here, in my opinion. But this is what they decided for, and at least you do get all of those features, so that's nice enough to have. In terms of power connectors, we get two 8-pins up here, and honestly, a single 8-pin is capable of handling easily 400 watts. There's no problem pushing that, because this has 4 ground connections, 4 12-volt connections, and even by the lowest spec of this connector, you're looking at least 8.5 amps per pin. If you actually have like a better high current connector, which this motherboard at its price point should really have, and you have a good power supply that doesn't use completely, crap cables, the 8-pin on the motherboard would be plenty to actually handle the power, any amount of power that a 9900K would want to pull, except maybe LN2 setups where using an extra 4-pin could help out. In terms of the power handling situation. But honestly, like having two 8-pins for Z390 is really rather unnecessary. If it was an 8-pin and a 4-pin, I would totally understand that, because, it would, like, the 4-pin would at least take a decent amount of load off of the 8-pin. And there are some power supplies which apparently have issues with, like, the power supply side modular connectors getting rather hot if you pull a lot of power through an 8-pin power connector, which is more like a problem with the PSU you're buying than the actual motherboard. Like, the PSU shouldn't have that problem, as far as I'm concerned. But yeah, for the motherboard side here, like this is really, really unnecessary on Z390. 8-pin is plenty for any ambient overclocking. 8 plus 4-pin would be really where I would stop for LN2, though there's definitely no harm in having the full 8-pin at that point, because if you're doing extreme overclocking, your power supply probably has enough connectors to run dual 8-pins at the same time. Now, another connector we have here is a 6-pin for the PCIe slots, which since this doesn't really have it, like, between the fact that, like, NVIDIA is straight up killing more than dual GPU setups, like, it's not supported anymore with the RTX 20 series. Like, on the 1080 Ti's, you could at least run 4-way for, like, Firestrike and various benchmarks. With the 20 series, you can't even do that. So with NVIDIA straight up killing, large multi-GPU setup support, this connector gets really unnecessary because, well, it's the main function of that power connector is to basically help out the 24 pin when you have a lot of power hungry PCIe devices. And it's not like I would recommend running like somebody might want like a RAID card or something, which can get very high power consumption in with certain high-end ones can get really high power consumption. The thing is, you still only have 16 PCIe lanes here. Like, that is probably not going to work out for you. So yeah, it's just this seems rather unnecessary. If they had the PLX chip, I'd get it, because you could like cram this full of various expansion cards. But as it is, like, you still only have 16 CPU PCIe lanes and 4 from the chipset on this slot down here. So I'm not sure what this is supposed to power. I guess somebody might run 4-way RX 480s on this or something, like, because that's like the only thing I can think of that would really necessitate the 6-pin. Or some other, 4-way, 3-way GPU setup that pulls a lot of power from the PCIe slots. But for normal builds, this is pointless. And also, if you are actually like going to be using this, like, this is like the worst place to put that connector, just because you're either going to have like power cables going like that across the motherboard or over all of the GPUs, which just like in a normal build is going to be really, really awkward. And I wouldn't run this motherboard, and I have my doubts about this motherboard's LN2 overclocking capabilities, because there is a serious lack of low dropout regulators in this area of the, well, really just around the entire area of the CPU socket. There's just not, there's for LN2 on basically all of the modern mainstream 14 nanometer CPUs from Intel, there's a bunch of minor rails on those CPUs that you need voltage control over. Otherwise, they cold bug at minus 120 degrees. And you really can't do anything about it if you don't have those voltage controls. And normally, the way those are implemented is with a bunch of low dropout regulators sitting somewhere around the CPU socket, except there aren't any of them on this motherboard, at least not that I can see in the pictures that I've been provided. So yeah, this like, so like for an extreme overclocking board, this could make some sense, because there you might actually have a use for 4-way crossfire, 4-way SLI. But it's just like, well, SLI still wouldn't work because there's no PLX chip. But it's just like, you don't even have the necessary, it doesn't look like you have the necessary voltage regulators to go below minus 120 degrees Celsius. So that again is just like, for a motherboard that's called Godlike and costs $600, not having a couple, $3, like what even $3? $1. They're like 3 amp LDOs. They don't cost anything. They're like $1 a piece, and they don't seem to be here. So that is just like right off the, like, that basically in my eyes disqualifies this motherboard from like extreme overclocking usage. Because it's nice that, we have this really solid VRM up here, which we're going to get to very soon, but there's no, like, the board's going to shut down at minus 120, and that's that. And you're never going to get to use that VRM at lower temperatures, and that's where you max out the CPU, You need to go cold first before you can crank up the voltage. It doesn't do anything for you if you shove 1.9 volts into a CPU at minus 120. It's just not going to do anything. So yeah, the lack of the sort of LDOs in this area is kind of concerning. Another overclocking feature that MSI has included is a clock gen right here from Integrated Devices Technologies. So yeah, it has a clock gen, which is pretty standard for all of the like going from Z170 forward. That's pretty standard on high-end motherboards to have a clock gen, because Intel split the BCLK regions for the PCIe, SATA, and I think PCH from the memory and CPU BCLK region. So you can actually clock the BCLK on like Skylake, KB Lake, Coffee Lake Refresh really, really high. And so you need a clock gen for that, since that's the only way to go beyond the frequencies that the Intel CPUs can normally be set to, because your BCLK normally tops out at like 130 or something, just in terms of what the CPU is capable of doing on its own. And then with a clock gen, you can go up to like 400 megahertz or something. Not that it's actually practical to do that, it's just a possibility. Anyway, that pretty much covers the sort of the random fluffy overclocking features that this motherboard has. It's like I'm not really impressed, mostly because of the lack of a PLX chip and the lack of the and what seems to be a complete lack of the extreme overclocking voltage controls. So anyway, let's move on to the VRM, because at least there's something nice about this motherboard. So this motherboard does not support the iGPU whatsoever. There's no iGPU output on the rear of the motherboard, and so this VRM right here is all V-core. And it has a lot of phases. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 phases. And these are pretty much real, as the motherboard has international rectifier IR3599s on the back of the board. And there are IR3599 doublers on the rear, and these are what I would consider a dumb doubler, because the key feature of an IR3599 is that it can do quadrupling. Like, that's the primary purpose of those, is that you can build, like, in theory, if you wanted to, with the voltage controller we have here, which that's a IR35201, with a 35201 and as many 3599s as this motherboard is running, you could in theory build a 32 phase. There's a couple gigabyte boards that have done that in like the past on platforms where it makes zero sense to do that, but Gigabyte at the time had a thing for phases, so they had to have more of them than everybody else. So they built a 32 phase with the 3599 and a different voltage controller. But with the 35201 and 3599s, you could also do a 32 phase. But because of that, the 3599 doesn't really have any advanced like current balancing features. So basically, it just takes the PWM signal coming from the IR35 from the 35201. The signal goes into the 3599s, and then the 3599 just splits it in between between two phases, and it doesn't really worry about if one phase is pushing more current than the other. Which leads to slightly less than ideal efficiency for a doubling scheme. If you have proper current balance, you can get even higher levels of efficiency, marginally so, than if you don't have any current balancing whatsoever. But considering the power stages that MSI is using here, the current balance really doesn't matter. Like, there's way too many phases, and the phases are too good. So the actual power stages used here are TDA. Wait, what the hell's that? That's a 4, not an A. These are TDA 2 and, or is it 21462s from Infineon / International Rectifier, because Infineon bought International Rectifier. So these actually have the International Rectifier logo on them, but it's, you know, it's all Infineon at this point. And this is the smaller sibling of the TDA 21472. Which MSI has used on some other motherboards. This thing is only good for 60 amps output instead of 70. But it does come in the larger packaging. So these are rectangular power stages, not square ones. So these should be really easy to recognize for anybody who watches a lot of my videos. And there are some benefits to the larger package. Basically, they have better thermal dissipation as a result of the larger packaging, since they have more surface area. So that's nice. But these are just 60 amp parts, not 70 like the 21472s would be. And unfortunately, the entire TDA 214 series of components, just no data sheets. They're completely just covered in NDAs, so I can't get my hands on them. And if I did have my hands on them, then I still couldn't talk about it because they're NDA'd. So instead, I would use the data sheet for an IR3575 to get like a rough idea of what you would be looking at with some other top-end 60 amp power stage from International Rectifier. Also because the IR3575 data sheet is one of the few 60 amp power stages that IR has put out like a full data sheet for. So you do have a really, really powerful like 16 phase VRM here. And the end result is that for a variety of settings at 500 kilohertz switching frequency and 5 volts gate drive. Now, the problem is I do believe that the TDA 21462s will be slightly more efficient for any given switching frequency compared to the IR3575s. and also slightly more efficient across the voltage range that you're going to be running into them. Like, because they are the TDA 214 series of parts are spec'd at 1.8 volts, along with basically all of the other new large power stages, which these are actually smart power stages, so they integrate very accurate current monitoring and temperature monitoring directly into them, as well as over current protection and over temperature protection. So these are, you know, very, very, very clever. The thing is, the IR35201 basically sees them in groups of 2. So it doesn't actually see them as individual phases, which is why the 3599 is like a dumb doubler, because normally there are ways to basically have voltage controllers and doublers that will then, the doubler will still tell the voltage controller that there's one phase, because the voltage controller literally can't control more than, you know, whatever phases it's spec'd out for. But the doubler then can actually current balance the phases itself if it has the logic to do that. And there are some doublers out there that do that. They're just really, really expensive in general. So, and you'll see them used on like top of the line X299 motherboards a lot. And recently Gigabyte has just crammed them into sort of their mid-range lineup because they're using an ISL voltage controller and they wanted a doubler. And I guess the 6617 was just kind of what they already had, because Gigabyte was using that part for X299 motherboards as well. But anyway, back to this board. 500 kilohertz, 5 volts gate, well, just drive voltage, which is the voltage that the power stages use to switch the MOSFETs on and off, as well as to run all of their internal logic. So at these settings, for the sort of various currents that you would run on LGA 1151, and I've actually okay, let's see. So air cooling, well, let's just say ambient. That'll make it simpler. So ambient, and you're going to have a current range, depending on what CPU you're on, of about 150 amps. I'm not going to include the 9600K just because that's an i5, and I don't know why on earth you would stick that into a $600 motherboard. Quite frankly, I don't know why you'd put a 9900K on this motherboard either, because again, there's no PLX chip, there's no I still don't get what the appeal with this motherboard is supposed to be, because it just looks like a lot of, like, I know with all of the armor on it, it looks really fancy, but under the armor, I don't see anything that fancy. So I don't see yes, it has a really nice 16 phase. You don't need that. Like, you really, really don't need that. You just need a good 12 phase or a good 10 phase. Hell, even a strong 8 phase would be perfectly good for Z390. And anyway, so 150A to about 200A. So 150A would be sort of 8700K territory, and we're at this range, we're talking up to 1.4 volts. Mind you, this is really hard to cool. As I recently found out when I started overclocking my 8086K, if you're going to run AVX, which is where you're going to hit these kinds of currents, it is very hot. Like, really freaking hot at this kind of voltage with these kinds of currents. But anyway, so the 8700K, as well as, surprisingly enough, well, not surprisingly, if you actually follow CPU, if you do a lot of power testing, it's kind of obvious that this would happen. But the 9700K actually sort of 9700K, 8700K both sort of match each other on the vCore current pull, because this has hyperthreading, which literally just makes each core do more work and therefore use more power. And the 9700K has more cores, but no hyperthreading, so each core does less work, which actually makes, the 9700K, in my opinion, is going to be a really nice CPU to overclock, because you're going to have much lower thermal density compared to an 8700K. Like, an 8700K is just really, really thermally dense, because you're doing roughly, each core, if you're actually fully using the hyperthreading capabilities, you're looking at about 30% more work done on each core, which translates to about 30% more power consumption and about 30% more heat being produced by each of the cores, which makes the 8700K really, really hot. The 9700K, therefore, could end up clocking higher just because it's easier to cool due to the lower thermal density, due to the lack of hyperthreading. The 8700K, 9700K, they're going to be looking at about 150 amps of current pull. And at that point, this motherboard should be producing about 17 watts of heat, which is great. It should have no problem dissipating that, as long as all of the plastic armor on top of the heat sinks, doesn't insulate the heat sinks too much from being able to dump their heat. Because ultimately, you can build the best VRM ever, and if you put it under a pillow, it's still going to overheat, just because that's what thermal insulation does. Anyway, 200 amps, which is where the 9900K should land if you can actually run it at 1.4 volts, which that'll be interesting to see, because that should be that should just be hotter than the 8700K. At that point, you'd be looking at about 20 watts of heat output for the 200 amp current figure. So, great efficiency for the VRM right there. Like, we're like, this is basically comparable with a lot of like high-end GPU VRMs, and GPUs generally get much better VRMs than motherboards because GPU cores pull way more current than the CPUs. But now that Intel just keeps cranking up the core counts, and we're still on 14 nanometer, the power consumption on the Intel CPUs keeps creeping upwards. So the motherboards are starting to approach sort of GPU VRM specs. And the end result is that this like gets really nice efficiency. So the VRM is definitely nice, and if it could run on LN2, then for extreme overclocking, we're gonna sub-zero settings, so dry ice and liquid nitrogen, you'd be sort of looking at the following current draws in this range. So you'd be looking at about 250 amps, which I would expect on about dry ice with like a 9900K. The 9700K would really move to like that 200 amp figure, or the 8700K would move to that 200 amp figure. Just, it's not going to like, these aren't going to suddenly jump, like these aren't suddenly going to jump in front of the 9900K. But so 250 amps for some dry ice overclocking, you'd be looking at about 24 watts of heat for the VRM. So again, just absolutely no problem dealing with that. And then going up from that to 300 amps output, which that would be like LN2 with a cold bug, should hit around that 300 amp figure, because you should be able to run up to around 1.65, 1.7 volts-ish. You'd be looking probably around 30 watts of heat output for the VRM, which again, just should be no problem to handle. In fact, you normally run LN2 without any heat sinks, because on LGA 1151, with how cold you can get these CPUs, what tends to happen is that the heat sinks just turn into a massive condensation magnet, and you just end up with an absolute lake in the VRM area, which is fine if you have really good insulation, but if your insulation isn't on point, then you can very easily end up just like killing a motherboard, because all of this freezes over while you're idling. That just will freeze over. And then you go under load and it'll defrost by melting all of that into water. And then it'll freeze over again, build up more condensation, and then defrost again. And it'll just get wetter and wetter and wetter the longer you run. So, yeah, having an overkill VRM that doesn't even need any cooling actually tends to be very helpful if you don't like going overboard on the insulation. Then LN2, assuming like if this motherboard, again, I don't have pictures of the back, so I'm not sure if the LDOs are just hidden on the other side, but I don't know. MSI has kind of stepped out of the extreme, like LN2 extreme overclocking scene recently, so I wouldn't be surprised if those LDOs really just aren't on this motherboard. So it might not even be able to go cold enough that you could run enough voltage to hit the 350 amp area, which the 9900K should be able to do in terms of current consumption. Under full multi-core benchmarks, you'd still be looking at only about 37 watts of heat output on the VRM, which again, like, should be no problem for the VRM to handle. And then just for the purpose of seeing how it would scale up past that, 400 amps, which I don't think is actually achievable on any of the CPUs that'll fit into this socket. You might be looking at about 44 watts of heat output for the VRM. So yeah, you have a really solid V-Core VRM, and that's really nice. It's just that the rest of this motherboard is just kind of like, I'm not sure what else. You can get a good enough VRM for ambient overclocking on cheaper boards, like much cheaper boards. This thing's insanely expensive, and this VRM doesn't really make much of a difference to the fact that this is insanely expensive. At this price point, even with this VRM, hell, if they cut back on the VRM and gave you some actual features like a PLX chip, or let's say, the LDOs, they shouldn't charge extra for them. Quite frankly, those shouldn't make a difference to the price. But a PLX chip would be really, really welcome, in my opinion, on a motherboard of this price point. Like, not having a PLX chip is just really weird as far as I'm concerned. Anyway, minor VRMs are actually also really, really solid. So down here we have the VCCSA and VCCIO. These are both minor rails, so I'm not going to bother going over the actual heat outputs. They're fine. There's never been a board where these would actually be a concern. Even on like the super low end, these just don't pull that much current. Both of these are controlled by this chip right here, and that is a chip from ROHM Semiconductor, so ROHM Semiconductor, and that is a where is it in my notes? 3205. And for the Mosfets, MSI is using their favorites, recent favorites, the 4C024N from On Semiconductor, and I've just realized that I don't have enough space in this area, and a 4C029N. And these are actually like MOSFETs that they use for like their main phases on a lot of the cheaper motherboards, and these are good MOSFETs. Like, I like these. These are actually really overkill for the purposes of VCCSA and VCCIO, as these are normally used for like straight V-core power on a lot of other motherboards that MSI makes. And the 4C024N is a 2.8 milliohm RDS on MOSFET, which is like, for as far as cheap motherboard low-side MOSFETs go, this is probably the best low-side MOSFET on cheaper boards out there. Like, MSI currently holds the crown for that. Yeah, and here they're just using it for VCCSA and VCCIO because they have a ton of these because they use them on a bunch of other boards, and it's just like, well, they're overkill for this, but I mean, next to this VRM, this, quite frankly, isn't that overkill. Like, these could have had 2 phases or something, and it would have still been like, yeah, next to that 16 phase, that still looks kind of like a reasonable motherboard design decision right there. So that's your VCCSA and VCCIO. Moving on to the very last of the VRMs, we have VDIM, which is a 2-phase. And unfortunately, I don't actually have the data sheet for this chip because that is a monolithic power system, so MPS, MP2940 voltage controller, 40A. And this thing's really annoying. Like, it comes up on their search function on their website, but there's no actual, like, there's no dedicated, like, data sheets or, like, anything about the actual chip itself. It's really weird. It's like they wanted to list it, and then somebody just decided, no, we're not going to put it on our own site. So that's kind of weird, but it does seem to, like, it is capable of, it should be capable of running a proper 2-phase. So this is, and it would make sense that on a motherboard of this price point, you'd have a real 2-phase memory VRM. So that's your VDIM right there, and or VDDR, depending on what you want to call it, or VDDQ if you want to use the JDEC term. And the MOSFETs on there are still, 4C024Ns for the low side, so massive overkill, and a 4C029 for the high side. Again, from On Semiconductor. So that's a really, really solid memory VRM right there. And that covers it in terms of basically everything on this motherboard. Very, very expensive, and I mean, you do get a set of really solid VRMs, but I don't see, like, I'm not seeing $600 worth of VRMs. Like, just no. That's just not here. And even if there was $600 worth of VRM, you don't need $600 for a 9900K. Not like, you like, it just doesn't make sense. I know the 9900K is expensive, but this is just kind of silly. The price tag on this motherboard is just insane, and the equipment that it comes with doesn't really reflect that, It's just, it's a high-end board, definitely, but, like, I don't know, who likes overspending on a VRM? I mean, it doesn't even have it doesn't even support the iGPU. It's nobody's going to use it for extreme overclocking just on the basis that it's a 4DIMM motherboard. And that's ignoring the fact that it doesn't seem to have all of the necessary LDOs for extreme overclocking. And then it's just like, so what, where's the 600, like, where's like the key feature of this motherboard as far as I'm concerned? Because it's like, you don't have a million PCIe lanes because there's no PLX chip. You have a solid VRM, but you can get solid VRMs for a hell of a lot cheaper than this. So yeah, I don't get what MSI was trying to achieve with this right here. You know, it is impressive, but it's just too damn expensive. Oh, and on the last note, MSI has said that basically all of the capacitors scattered around this motherboard, so like these guys, and I assume these guys as well, are all made by Nippon Chemicon. So they call them NCC capacitors for short, but they are Nippon Chemicon, and that's a Japanese cap manufacturer. They're really like well regarded as far as like their capacitor reliability goes, and their capacitor specs as well. So this is basically like equivalent to your like what say Gigabyte and ASRock and Asus will use on their higher end motherboards is like Nichicon FP series capacitors. That's basically equivalent here with the MSI motherboard, but yeah, it's just like, and even then, it's like these capacitors could have been made out of solid gold and diamonds, and I'd still tell you, like, it's just not worth it. So, impressive, but overpriced is ultimately what I think about this PCB right here. It's just like, I don't see it. Where's the, like, I maybe, like, I'm not actually sure how much the TDA 21462s are, like, cost. And they're probably pretty expensive, but there's better, like, that still doesn't justify the price point as far as I'm concerned. Like, it doesn't, like, it's just like, you don't need them. So why? So that's it, you know? That's the Z390 Godlike from MSI. It has a really impressive 16-phase V-Core VRM. It also just doesn't make any sense in terms of everything else on the motherboard, because it's just like there's a whole lot of VRM attached to not a lot of motherboard as far as I'm concerned. And then it has a $600 price tag. So that is it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support Gamers Nexus, there's store.gamersnexus.net. There's like shirts, mugs. There's also the mod mat that you see in the background of the video. And if you'd like to see more overclocking related content, I have a channel called Actually Hardcore Overclocking, where I do more overclocking stuff like PCB breakdowns, live streams, and modification guides and all kinds of other overclocking related stuff. That's it for the video. Thank you for watching, and goodbye.